Hello, everyone out there, and welcome to another Nelson's Corner, an informal look at various topics in C#. Okay,
So,
I just wanted to say.
So that's the name we're going with then.
It just sounded good.
It does, it does.
With your host, Nelson LeKay. Hey, Nelson!
Hey.
All right. Joining along for this ride to learn about the wonderful world of .NET and C#, we have Mr. Zach Parrish.
To have my programming skills completely pwned and noobed in front of the community.
No, you're supposed to say you're a noob and you want to learn.
I'm fine with that.
So if you don't learn, Nelson has failed. So you can't fail.
Yeah, it's not really me in the hot seat then.
Yeah, there you go. So you just got to look at it from that angle. As your referee, Mr. Jason Busby. That would be me, guys. And yeah. So, anyways, this is the second episode. We have started with the first episode with the topic being to take a look at LINQ. Now, of course, to explore what LINQ has to offer for C# developers, there were several subtopics that needed to be covered to kind of get Zach up to speed, because Zach is not a complete noob in the world of coding.
But nor am I a native programmer.
True. But, Nelson didn't want to start out with this is a variable.
Right.
A variable is, that just wouldn't have been any fun. But those subtopics that Nelson touched on in the last episode were implicit typing. He talked about enumerables and enumerators. We talked about generics. We talked about extension methods. And we got all the way up to the discussion of lambdas. And I kind of put on the brakes,
rang the bell, and sent everybody home.
Because there's a lot that can be talked about with lambdas. And Nelson's gotten pretty excited about it over the last 24 hours and has put together a pretty, well, it sounds like a pretty in-depth discussion. Is that accurate, Nelson?
Yeah.
That's awesome.
So let's jump in.
So with that, Nelson, I'll just hand it on over to you and your student, Zach.
Well, first of all, Zach, did you...
Oh, it's going to be evil. I heard him laugh.
Yeah, I heard the laugh. I'm a little anxious now. Did I what, sir?
What do you remember about the last video? Is there anything you could throw up or...
Anything I could what, sir?
Throw up on the screen or anything? Any...
Look at he just goes right for the heart, man. Here, put your hands on the keyboard and...
Anything I could throw up. I'm not sure what you're asking. Give me like a particular question, and I can do my very damnedest to either answer it or code it out for you.
All right. What is a generic and why is it useful?
A generic is a way that you can specify a method, basically a way to write code that is not type dependent, so that you can specify the type later on while you call on that method, or does it work for variables as well?
No.
No. Okay. So is it just for methods?
Yes.
Okay. Then at least I got that part of it.
What was that, Nelson?
Methods, delegates, structs, and classes.
Right.
And types, basically.
Right. Okay. So what would you like me to try to do here?
Well, what about maybe going on about...
Let's see if I can do this. What if I try...
Oh. There's not a name in that method.
Oh, yeah, I got to put a name in there. Oh, this would be this. Method. And let's see how much I remember. Actually, let's just call this anything. Now,
Ready?
all right.
Now, at this point, you...
I need to put some arguments in there, yeah?
You can, if you need to.
Well, let's say I don't need to right now. And let's see. All right. Now, I could put something in here. Now, let's see. I'm trying to remember. Dot right line, and it probably doesn't matter what I put in here, but let's just say.
Sweet.
So now once I get out of here, I could technically call on this.
Well, at this point, the generic, because it doesn't have
it doesn't really have any type dependent aspect to it.
So it doesn't really do anything at this point.
Right. But I mean, I got the syntax down, and I understand, what we're here to do. Now, At the same time, hang on, I'm thinking. What if we passed in something like? Yeah, I don't know. That's going to be the end of it for right this minute.
Alrighty. Well, at this point, you can use T anything as a normal type.
Right.
Unfortunately, you can't use it for things unless you supply type or generic constraints, which is kind of out of scope. But just as long as you understand that T anything within the context of this method is whatever the method invoker defined it as.
So, okay, hang on. So let me try something. So I should be able to do... No, I can't do that.
You can treat it just like T anything is just a normal type. It's like int, float, double.
He's thinking.
I'm thinking. All right.
He's got his game face on.
So let's see. We call this argument 1, and then let's say we, instead of doing all this crap, can we just say arg1, or we have to say that outside the quotes? My syntax is so bad in here; it's terrible.
You have to specify that outside of the quotes because a quote is a literal string.
Right, right.
Argument. So sweet.
And then that I should be able to call on and feed it any kind of type that I want, from a string to a float or whatever, and it should basically just put that up in the console for me.
Yes.
So, are you going to throw that up here?
Yeah, go ahead and do a call to it.
All right, let's see. So we could say my method, and let's just pass this back to what we were doing earlier.
Very nice.
Hello, Nelson. Smiley. And so that would work. And then if we wanted to, I suppose, there's no reason why we couldn't say my method and 3.14. No.
Yep.
Okay.
You see that it turns into a double up there?
Mm-hmm, mm-hmm. So we should be able to call it and send it any type of data we want.
Correct.
Now, I did have a question about this. Now, in my case, I'm doing something so amazingly simple that it's almost embarrassing. But what about situations where you've got functionality inside your method that really is going to be type dependent? I mean, of course, there are functions that only work on strings, or if you're doing int parsing, you can't do that to a string. So how do you handle that inside your method in case you send in some sort of data that isn't necessarily compatible with the functions of that method?
That comes into generic constraints.
Okay.
Essentially, can I grab the mouse for a sec?
Go for it.
It's all yours.
Essentially, you just specify where arg1 is an int. And now that obviously isn't particularly useful because you might as well put an int. But where this is useful is that you can specify an interface or a base class that this has to define. And if I were to do that, if I were to do IEnumerable, well, see here, the thing about generics is that they really come into play. You can accomplish everything that you can with the generics without generics.
Okay.
The beauty of generics is being able to do it in a cleaner way. Does that sort of make sense?
It does.
See, for example, there's and I hope this doesn't get off too much of this scope here, but there is an array list that we can go ahead and include. And this is a completely type unsafe list of items. So we can go ahead and, hold on. We can go ahead and say add and then pass in anything we want. And the problem with this is that we have no constraints as to what type of arguments we can pass into this.
Right. So we don't really know what's going to come out.
Right. We can stuff whatever we want, and we don't know what's coming out. So we do items 2, and then let's say we want to get the first element of that, and you do dot, and you don't get anything useful. You just get the basic functionality. On the flip side, if you go ahead and turn this into a list of integers, which aren't currently included. There we go. A list of integers. At this point, this now becomes invalid because it's not an integer. You're constraining this to a particular type. So string is no longer valid in the context of integer. But the benefit is when I do items to dot, and this might not be a great example, but there we go. You have a compare to that takes an int. This isn't a particular good example, so I'm going to switch this around and go to string. And now this becomes invalid because it's an int. We pass in a string, hit control dot, and we get all the string methods.
Mm-hmm.
So essentially what I'm saying is that generics don't allow you to do anything that you couldn't already.
Right.
It just makes it cleaner and more type safe. And the biggest use of generics are in frameworks and collections, like you see with list, linked list, dictionary, tuple. Well, that's not really a collection, but that's another example of using generics properly. But unfortunately, I would love to go into this in way more detail and actually write out, some of the examples, being able to write generic factory classes, for example, but that would probably take a lot of time.
Sure. And we don't want to branch too far away. Really, what I was thinking of is like situations where, because you have to write your own functionality within a method in the first place. If that functionality needs to change depending on the type of data that's being passed in, what is a way possibly one might go about handling that?
With generic constraints. So
right, exactly. And that's, I think you addressed it. I was just trying to tell you this is more like where I was coming from.
Right, okay. So sweet. Was there anything else about generics that?
No.
Yeah, we can definitely take a time at some point, Nelson, to just have an entire.
We could have an entire corner, I'm sure, on generics and their application.
There are loads of stuff that could be talked about.
This is, like you said, this is completely useless, and you shouldn't ever do this if your goal is to just print something.
Right, of course. But
the reason why
go ahead.
it works is because WriteLine has an object,
mm-hmm.
an object overload, and if we were to replace this generic, completely remove generics out of this, and just have an object being passed in, everything will work just as normal. So that's an example of why this is particularly useless.
Right.
Okay. So I just wanted to maybe get people familiar with the syntax so that when they see LINQ, they don't freak out.
I did make it through the syntax. Honestly, that's like the first lines of C# I've written in probably over a year. So
yeah, you sit in on the videos, but
I sit in on them, but I don't actually type the stuff. And so I get exposed to all the concepts, and I understand what the concepts mean, and I actually keep them in my head really well. But as for the sitting down and typing the stuff, I don't ever do it.
All right. So if there aren't any more questions that I can answer quite terribly.
No, I think we're ready to move on.
No, that's
okay.
Rock and roll.
So understanding lambdas, the prerequisite of understanding lambdas is that you know what a delegate is and why it's useful, because essentially a lambda is a cleaner way to define.
Go ahead, I'm sorry. I was just going to say, I've heard the word, but I'm not really familiar with delegates, so...
Okay, and I'm going to be spending a little bit of time going over delegates, what they are and what they do.
Cool.
A delegate is a type, and a type is anything you can make a variable out of. So, for example, int is a type. So is program, because it's a class.
Yeah.
And if I were to define an enumeration up here, if I were to define an enumeration up here, I could say test and then a value and do something. So that is what determines a type, because you can make a variable out of it. It's not necessarily instantiatable, but it allows you to reference it with the variable.
Okay.
And a delegate is another type of type. You define it with a special syntax, and that special syntax kind of looks like a function because that's kind of what a delegate is. So let me go ahead and do this. So that is an example of a delegate. And what a delegate allows you to do is to reference methods or to stuff a function into a variable. That isn't mind-bending enough.
Okay, let's just say I follow you that far, but give me an example to make sure that I do.
Okay, so let's say that we have a function over here. And so now, because it's a type, I can assign it to a variable and an argument, so it is valid within that context. So now I have a function pointer being passed in, and I know that still doesn't quite make any sense.
Well, yeah, it doesn't just yet. And you started throwing out even more words like pointers, but we won't get into all that just yet.
Well, the reason I say function pointers is anyone who's familiar with C++ out there, but I realize that doesn't really apply right now. Okay, so we have a method that takes a delegate and calls a special method on that delegate called invoke. Now what you can do is you can go up here and define another method. So here's a method that I'm writing, as a part of my code. And I can go ahead and assign that method Okay.
Okay, so basically you've taken the functionality of not important and I guess you've stuffed that method into a new variable called del, which is of type myWorthlessDelegate.
Yeah, think of this. If he says int x equals 5.
Right.
So we've stuffed a 5 in
Right,
x.
right. Yeah,
so here with myWorthlessDelegate, that being the type, del being the actual variable, think of the variable now as holding that.
Holding that
method.
method. Instead of looking for an integer or double or a string, it's actually looking for a method to come in.
Yeah, that's going to match. And he'll talk about matching signature and all in a minute, I'm sure.
So at this point, we can now pass this variable around as normal variables. And like I demonstrated down here, we can pass it in as arguments. So I can go ahead and say do something and pass in a reference to my not important. Now, based off of what this code says, what do you think it's going to do?
It should just print your right line, won't it?
And do you know why that would happen?
Because you've already assigned not important to the variable del, and now do something is just going to call on that.
Yep. And so if I were to run this, we get that right line.
Right.
Okay.
Now,
so,
now let me ask you this before you go too much further. To what end would one do this? I mean, why not just call a function outright? Why stuff it into a variable so that you can call it?
Let me say this while Nelson's thinking for a second. And that's an excellent question, and that's a problem with many of the books that are out there, because many C# programming books that are walking you through what delegates are, they're going to use very simple examples like this.
Sure.
And your average reader is going to think, your beginner to programming is going to think, why don't just call not important? That makes more sense because this is a lot more typing.
Is it a scope issue?
It really comes down to more. You need more complex examples to really understand where the use of delegates becomes powerful and important.
And I do have an example in mind, but that is going to require that I introduce one more thing into delegates. That you notice how the signature being the return type and the argument list, this delegate, so in this case, this delegate defines the signature of void with no arguments. So that makes it compatible with this because it's no arguments and it's void, which makes this a valid statement. If I were to give not important a argument,
then this shouldn't work anymore because the delegate defined.
Yeah, you can see the error right
there.
Yeah,
it already defined a method that should be taking an argument but has none. Or other way around, sorry. It should not have an argument but has one, so you can't do that.
So if I go ahead and say that,
then you should work again.
Yep. And at this point, the call site is actually acting up because now invoke expects this argument. Because this delegate defines an argument. When I use that delegate and I invoke it, it expects that I pass in the argument as a part of the invocation. So now that you have that, also note that you can give return types.
Okay, yeah. If you can
So
say
I-
void, you should be able to say anything.
Okay, so now I'm going to
Can you have
write.
generic delegates?
You can, and those are definitely going to be talked about later because they become incredibly important.
Okay.
So I'm going to go ahead and write an example.
All right. You are going to walk me through what it is you're typing here, aren't you?
Oh yeah. I just want to quickly get this example going. Okay, so based off of what you know about programming, what do you think this program is going to do?
Ooh, let's see. Well, we're defining a list first off. That list is going to take in. Actually, I don't play with lists like that. My experience with lists almost limits itself to the world of arrays, and arrays here inside of C# are not necessarily like arrays that I play with inside of Mel day in day out. So let's see. All I can do is just step down to the next line and then just kind of go from there and work my way back up.
I'd say start right here.
Well, we're defining a new list, and we're adding some things into it, being the numbers 10, 20, and 4. And then we are calling on that list. No, well, see, that jumps me back up to less than 5, which I haven't really looked into yet and exactly what that's doing. So that looks like it's just going to take an input, check to see each one and see, well, take in a list, see if each item in that list is less than 5, and then store it if it is. And then return everything that it's found. And so, let's see, then we get back down to the next for each. It's going to take everything that was found in there and print it out to the console.
Yep.
So
if I run-
in the end, we should just get 4. Yeah.
Okay, so at this point, this is a very specific function that does one thing, but it has an overarching kind of behavior to it, and that is filtering out an input and returning an output. But what if we wanted to keep the innards of this function completely the same behavior, except for we want to redefine what happens right here
Okay.
on a per case basis? Do you think you would be able to re-implement this using delegates to accomplish that?
No, not off the top of my head.
Okay, so the first step would be to define a delegate because we need to be able to, essentially our goal is to take what is in here and allow the caller of less than 5 to be able to put in whatever it wants to go there.
Mm-hmm.
Like, we want to be able to inject code right into line 17 and only line 17. So in order to do that, we will need a reference to a function that we're going to be using to break the code apart. And the first step of doing that would be to go ahead and define a delegate. Okay, so we
Why
have a
Boolean?
delegate. Because that is what this expression evaluates into, a Boolean.
Mm-hmm. Oh, okay.
This individual expression is the only thing we want to factor out, and this particular expression evaluates into a Boolean and takes a single integer as a value.
Okay.
So the first step would be to define our delegate so that we can now pass around functions that look like this and that meet this criteria of returning a Boolean and taking an integer. So now we've defined this type, we need to add it to as a parameter. And I'm just going to go ahead and call it where. And now that we have this predicate within this method, we can now call on this predicate or this delegate whenever we want to. So what I'm going to do is replace only the code that we wanted to replace, so the rest of the behavior remains the same, with where.invoke item. Alternatively, the equivalent to this is doing where and then a parenthesis and item. That is the exact same thing. The parenthesis is just shorthand for calling .invoke.
Okay. And I'm actually more used to seeing that.
Right. And so what we can do is, the first thing we're probably going to want to do is rename this method because it no longer only does less than 5, it does whatever we want it to do. Right. So we're going to call that filter, or filter list, or filter int list. So at this point, this code becomes irrelevant. And now, in order to call this, or that particular code doesn't, in order to be able to call this, we have to supply the second parameter. Would you have an idea as to what goes there?
No, I'm afraid I don't.
Okay, remember that a delegate is a reference to a function.
To a function, right. And the only thing we've been doing right now is checking to see if something is greater than 5.
Right. But at this point, we can now specify our own functionality that only goes in, now that's line 19. That's only where our functionality comes into play. So the rest of the method has the same behavior, except for we want to replace just what goes into 19 with a reference to a function.
And if you scroll back up, Nelson, just to throw in a little extra, you can see on line 12, let me reach over here and grab the mouse, that on line 12, he's defined a delegate called predicate. Okay, so his filter int list takes two things in. It takes a list of integers, and it takes a delegate. So that delegate that it's going to take in is going to be pointing to some function somewhere.
And right now, I think that's what's tripping me up. The delegate doesn't point to anything right now, does it?
Very good.
And that's why I'm having a hard time. That's why I think I'm locking up a little bit, because right now the delegate doesn't really do anything, and so it's hard for me to be able to say, all right, well, we should be doing this, that, or the other. When I guess at this point, what would have to go there on line 35, where you were pointing me a second ago, would have to be where, or some other reference to that delegate.
It doesn't necessarily have to be a reference to that delegate. It has to be. You have to specify which function you want to fill this. So in order to do that, you would define a function that matches the same signature as this, and then you would pass it into this function right here.
I think it'll become just a little more clear when he sets that up, because he's still got to set it up.
Very likely.
Okay.
So while he's typing, I'll just explain. So he's going to go ahead and create the functionality now. So here's the
function that actually does some sort of less than 5 or greater than 10 or whatever you might need.
And the key thing being it's going to return, true or false. And so now he needs to actually create. Go ahead.
Okay, now that makes sense.
And so we could really
now you can assign that to the delegate.
Well, it becomes assigned because we're passing that method name into a method that is taking in a
all right, I'm back with you now. It took me a second. I see what you're saying.
Now, yeah, he could have defined a predicate variable and assigned it ahead of time and then passed the variable
But that would be irrelevant at this point because it's already been assigned up.
It gets assigned when it gets passed in there.
Yeah.
Exactly.
So internally that's just looking for a where, and what he's doing down here is actually filling that in. So that's going to become where. So it's already looking for a function. It's already looking for that delegate. So that's what you put in there.
Yep.
Okay. It took me a second. Like I said, I think that's what was really throwing me off at the moment, was that right then we didn't have any methods that we could actually call on that stood out. I mean, we'd have had to go and create one.
And then you can finalize the demo here by right before that line. You could go ahead and create a variable instance of the that's pointing to one of those, and then pass that variable up to it.
Yeah.
Okay.
I'm with you.
Cool.
Okay. So does that sort of maybe explain the actual use of delegates? And this is one example, filter int list, but does that sort of explain how what you can do is you can remove code before and after a function and stick your own function right in between?
It does. It allows me to see how you could use delegates to alter the functionality of a method by swapping a function in or out.
Kind of a quick, cheesy, larger scale picture. Just think of some sort of graphic application like Photoshop.
Mm-hmm.
And again, just high-level thinking. So you got filters, and each filter you're going to apply to a pixel selection does different things.
Right.
So the functionality for each of these can be different.
Mm-hmm.
And so instead of having to, for coding things, if somebody comes in with new filters, they can specify what functionality will take place.
Right.
And then that functionality is going to be pointed to when that particular filter is being used. Those pixels get passed in, and it does the work.
Sadly, my brain always goes, when I run into things like this, my brain always goes back to Nintendo cartridges.
Okay. I was racing through for some sort of graphics
No, but you're right.
example
because,
for you.
because you used the word filter, so that was very nice. But yeah, I see what you're saying, and yeah, I see how you can use a delegate to alter the functionality of an existing method.
Yep. And so, I mean, that's pretty much delegates. You can define delegates as complicated or as simple as you want them to be.
Mm-hmm.
And that's just by changing this, and then you can use it like a variable anywhere else. So it's basically allowing you to use a delegate as a variable. And a few things about delegates. I'm going to actually switch this up here. I'm going to write another method called actually, I'm just doing this. So right now I'm encapsulating a for each loop. Screwed up syntax. With a delegate. And the cool thing about delegates, and this is how they're useful in a lot of other instances, is that each delegate can actually hold more than one reference to a single function. And this is incredibly important in a lot of different things. So let me demonstrate what I mean by that. So I'm going to define a print int. Again, I think I've already defined this in the past. Printlet int that just prints an item. And then I'm going to go ahead and say for each, so I'm invoking my for each method, input, and then I'm going to pass in a delegate, which is print int. So at this point, it's going to behave, like you'd expect it to, 724,
Sure.
724. Now, what if I wanted to subscribe more than one method to this individual delegate right here. In order to do that, I have to break it out into a actual declaration, meaning that I have to say do stuff with, let me call it functions. And now I can use the plus equals syntax to push a method. Right. C# does not let you. Actually, hold on. I'm going to initialize it with print int instead of initializing it to null, so that'll make more sense. Okay. So behaves the exact same. So what if I wanted to subscribe more than one method to this individual delegate? Let's say I wanted to again, these are a bit worthless examples, but this does come into play in the use of delegates to a huge degree, especially if you've ever done any Windows or other types of programming where there are events to deal with. I can say functions plus equals int with hello. So do you kind of understand what's going on here?
No. So when invoking the method now, there's a list of methods that it's going to call.
That it could, okay.
Instead of just the one, and that's when he did the plus
because of the
equals.
plus equals. Okay, add this functionality to what you've already specified.
So in this case, this becomes a bag of events, or a bag of method pointers, I guess you could say, or method
Basically,
reference.
we have an invocation list now, and so we're pointing to this, and when you invoke it, we're going to call everybody on the list.
Okay. Yeah.
Okay, so that is that's how events work. If, like I said, if you've ever encountered that, and they are just essentially delegates, and that's the syntax right there.
Okay.
So I remember you mentioning before that, asking if generics can be used with delegates.
Mm-hmm.
They certainly can be. If I go and say, use the delegate syntax right, or the generic syntax right here, and make this generic, now two things happen. You notice that do stuff with right here is now an error because you have to supply a t type to be able to use it like a variable, or an argument in this case.
Right.
But I don't want to restrict this method to having to define exactly what do stuff with does. So instead of supplying int here, I'm going to make for each itself generic. So, and then I'm going to supply a generic parameter into a generic parameter.
Okay.
So,
yeah, I'm with you so far.
And then at this point, I could also replace int with t-type. And now it all works. So this now works without any, let me make it more explicit here. So I'm invoking for each with int. So it's basically going to come in and copy paste int into every instance. And because we copy pasted the int into do stuff with, it gets copy pasted up here, which results in that. So that's what it kind of flattens out to when it gets compiled.
Right.
And it'll work just as expected. So that is another example of how generics can make your code, well, generic. Because ultimately, and this is a core principle of LINQ, ultimately we are doing things like we're filtering items, we're looping over them, performing some sort of operation, and we don't really care what the type is. We want the caller of LINQ to determine that for us. And what we can do with generic delegates. And one last thing is that the .NET framework actually supplies a bunch of delegates that we should use when we're doing stuff like this, and those are action and func. An action is a predefined delegate that literally looks like this. This is how action is defined. It is a bit different in .NET 4 with covariance, but that's not really applicable here. But this is what you can think of this delegate being defined as, and it's defined in the .NET framework. So I can actually remove that and it'll still work because action literally looks like that.
Okay.
It's predefined for you. And you'll see action a lot because it makes all your code consistent, easy to read. You don't have to redefine all your delegates everywhere.
Right.
So it's important to think about action. There's also func, and I can't use func in this particular example, so I'm going to erase that and go down here. Or no, I'm just going to go ahead and redefine func up here. So delegate t return func t return. The difference between an action and a func is that an action always returns void. An action always returns void, and a func always returns something. And the return values and the parameters to both of these delegate groups are always going to be generic. So you can use them in any case that you need a delegate. You can just use action or func. Use func if you need to return something. Use action if you don't.
Before you get completely away from all of this, talk to me a little bit about the syntax of delegates. I noticed when you're typing stuff out, we're getting some word changes over to things like internal and whatnot. What's the point? What's this all doing for us?
Internal is being applied by resharper for us because it's assuming that we need it.
Yeah, I didn't think you typed that.
No, I did. Internal basically says that this type that I've just defined, in this case action, is only available within this assembly.
Okay.
So it's only available for use within anything that is under console application 2. Okay. If I were to have another assembly that somehow referenced console application 2, you could not use action, or this action. You can use the .NET action. I'll rename this to make that less confusing.
Yeah.
You will not be able to use this in any other class library or application other than what it's defined in because it's internal. Okay. But, I mean, that's kind of... You can just nuke that, and the behavior is the same because we're all in the same assembly.
Right. Now, I think this was something that was already kind of implied, but I don't believe it was said specifically. When assigning a method into a delegate, is it really just the number of arguments that controls compatibility from one to the other?
It is the number of arguments, and it is the type of the arguments, and it is the type of the return type.
Okay. Which, if you go ahead, please.
It actually slightly changes with .NET 4 with covariance, but that's besides the point.
Okay.
I just want to point that out there to be correct. But you can. It's useful to think about it like that, like what you just described.
All right.
Okay, so we now have our for each that does stuff with an item, and those items are supplied by a list, a generic list that is determined by our call type. Now we can get into lambdas. I mean, do you understand delegates, how they're a pointer to or a reference to a function, and how you can use them everywhere? Is that concrete?
I do.
Okay, so basically with C# 3, the development team saw the syntax and said it was ugly.
Okay.
Essentially, we have defined two methods that are only ever used inside of this one method. And it's kind of useless to define these methods everywhere and only use them in one specific location. So what they did is they didn't invent this, they stole it from other languages, but they incorporated the ability for a developer to specify a function within the context of another function. All right. And let me show you. I'm going to go ahead and delete those two guys, and you'll see this turns red because now I've deleted that function.
Right.
But I still want to pass in a function. I still want to pass in a function that does the exact same thing as what this function does. Mm-hmm. And I do that by supplying a lambda. And I'm going to go ahead and write it out. Does that freak you out?
Not yet. It actually doesn't look too bad. It looks like you're specifying some thing that you're throwing in. Let's see, item. That's going to come... I imagine that's going to come out of your list, but I'm trying to see where else... Yeah, okay, that's coming out of your original list, and we're just going to be writing that to the console. It's just we're treating that like an inline command.
One of the things to remember that's handy when first learning this is the way that the lambda operator is read.
That's I was just about to ask. I realize that's not equal to or greater than.
Right, you read it as goes to.
Goes to, okay.
So that's item goes to console.writeLine item.
Yeah.
You can think of
We're gonna take this object and we're gonna do this to it.
you can think about this item
Mhm.
as the argument list,
Mhm.
and you can think about this one statement. In this case, it's only one statement as the method body.
That's what I was just
So-
thinking. It's like a way to write an entire method in a single line.
Exactly. And if I wanted to, I could, say int. So now I want to pass in the index to every one of these items. So I'm going to define an index up here, and I'm going to initialize it to 0, and then every iteration I'm going to add 1 to it, and then I'm going to pass in this index that I'm generating into the here. And I don't know why I did not use var. Sorry about that.
I forgive you.
So at this point, this delegate now requires a method to be passed into it that takes two types. One, the generic type that we specify at the call site, and two, an integer. And you'll notice right here we get an error because it says incompatible anonymous function signature, meaning that this argument list right here only has one item.
Right. And we need two things.
Right.
We need that index as well.
By the way, this wrapping it in parentheses, wrapping the argument list in parentheses is perfectly okay if there's only, that's how you normally define it. If there's only one argument, we can nuke these, and that's what you saw earlier.
Right.
But if there are more than one argument, you have to supply the parentheses.
Oh, I'm a nut for parentheses. I put them around everything when I can.
Right. So now we continue our argument list. So it'll be item, and then it'll be index. And so this is now the argument list of our inline or anonymous function. And this is now still the method body. And now that the argument list has an item and an index, I can go ahead and say item plus comma plus index. And I can run that, and I'll get that.
Get what it is, and then its index number as well.
Yep.
I mean, that actually made the whole lambda expression thing pretty easy, but surely there must be more to it than that.
But I mean, just the key thing to remember right here is that functionality that he specified on the right-hand side of the lambda operator, the console.writeLine. That is, you could look at that as getting packaged up into do stuff up above. So then when we're going through the loop and we say do stuff, that code down here that he's got highlighted right now, that console.writeLine, that's the functionality.
Right,
that's our function.
because all of that is in that second argument, and whatever's in that second argument gets passed into do stuff.
Right. So
but it's like that was so remarkably easy to understand that I can't help but think there must be more to it than
lambdas
that.
are ridiculously simple.
Yeah.
Well, that's the thing. They really just need to be explained. And there are a few things that you should note about lambdas. First of all, this is one statement.
I was actually about to ask, what if you have more than one piece of functionality you need to perform in your quote-unquote method body?
You do what you do in method bodies.
Okay.
And that is...
Put them
my
in
first-
curly braces. In braces.
And I'm going to go ahead and be nice and indent this.
Oh, you beautiful person, you.
And this is something I hate about ReSharper that I haven't been able to turn off, is how it likes to indent my multi-line lambdas. I hate that. Anyway, so
Actually,
now we...
I hate to be the voice of dissension, but I actually thought it was kind of cool, but that's all right.
Well, when you write the code...
Exactly. Exactly.
That was awesome.
Okay, so now we can do multiple statements. So let's just throw a console dot, and it'll behave just like you expect it to.
Yeah.
I'm hitting keys, and stuff is happening.
Right.
So that is how you supply multi-line lambdas. Now I'm going to go back into my filter int list example, so I can show you functs and how to deal with return values.
Okay.
In this case, this is going to be a generic method, so I'm just going to call it filter list. It's going to take a t, element, and then it's going to take a list that is a t element, then it's going to take a func that takes a T element and returns a bool. So remember that this,
Yeah, func has a return type, action does not.
right, and the last argument is always going to be the return type.
Okay, good enough.
So it takes the T element, returns a bool, and we're going to call this predicate, because I like that word. So then we do or not int, T element. So here we're going to take our delegate that we have right here, and we're going to say predicate, and then we're going to pass in our item, and then we could say equals equals true to make it more explicit, or just omit that entirely. It's perfectly equivalent. And then we're just going to say output dot add item, and then we're going to return output. And my screen kind of goes up there. All right. Okay, so now we have our filter list just like we had before.
Mm-hmm.
I'm going to keep this around, but I don't want it to run. So now we're going to say output equals filter list input. I'm going to leave this one blank as I write the output of this output. As much as I love Visual Studio, when you have a syntax error, it is just unforgiving. Okay, so now that that's written, I'm going to go back and uncomment this out. And so what do you think goes here?
Hang tight. Reading back through. It's going to have to be the equivalent of our function, so... I don't know. I'm sorry. I've taken up too much time. I should get the buzzer at that point.
Well, look down.
Okay.
Look down below at the for each statement.
Down below it? You mean at all the comments?
After this,
Oh,
he's then doing something with output.
right.
So what do we need up there?
No, I'm sorry. I wish you had lost me, but you did.
Okay.
Okay,
Sorry.
essentially we're going to pass in a lambda into this, but this is going to be a different kind of lambda. This is going to be a lambda that returns a value. So I'm going to go ahead and do my single, because this lambda that we're passing in has to match this signature, which in func T element bool means it has to take a T element and return a bool. And the C# compiler is figuring out what T element is for us right here automatically, because it is inspecting the type of this input.
Mm-hmm.
It sees input. It sees input as an int list. It then sticks that into this, extracts int out into T element, and applies it to everything. So it's kind of this complicated process. But in order to be more explicit, I'm going to manually supply int as the type parameter. So just to make things more understandable. But so now we have this item, and this is a single argument lambda, and it returns a value, and that value is going to be a Boolean, so it has to be an expression that evaluates into a Boolean. The simplest expression that evaluates into a Boolean is true. Do you have any idea as to what this code would print?
Is it just going to print true?
Mm-hmm. You have to read the argument list and then apply those up here and kind of go through this method body. So what we're doing is we're defining two things as a part of these arguments. We're defining the items that we're going to be filtering, and we define a predicate, which is a delegate that accepts a T element, which in this case is an integer, and returns a Boolean. And then we're going through this method body, and this method body, all it is it's a for each loop that selectively adds items to this output variable that is then returned. And it determines which items to add to this output variable by asking this predicate if it should or not. So if this predicate returns true, it adds item to output. If the predicate is false, it ignores this item and keeps on going. So predicate up here, if you go back up here, is a delegate that takes an integer or a generic, whatever you end up call set up here, and then returns a Boolean. And in this case, this is the predicate we are passing in. We are passing in an entire function or a method. It's just a really condensed syntax. So this is the argument list, which in this case is just a single item of type int, and it evaluates into a true.
So imagine if he wrote a standalone method right now that returned a bool and took in this item, and then inside the body of the method, he just simply typed return true. So then what happens when we get up here, as we're looping down through each item, when we do this if on the predicate, it's always going to return true. So basically you're just saying, if true, add the item. If true, I mean, I'm simplifying that.
Right.
Because that's all that's coming back from our expression, from our lambda. It's all good. No. I appreciate you being confused, and I'm sure there's a lot of viewers that are appreciating it too, because this is where things start to get challenging for people that are new to this.
I mean, I understand the concept of what the lambda is doing in this particular case. When you say what is this going to print, man, I couldn't tell you what this is going to print.
Yeah, I think writing that out is a good idea, Nelson. So that lambda expression right there that he just highlighted, and this static bool return true up there, yeah, exactly. They were the same thing.
So we're stuffing this function into this argument.
Right.
So that this argument now references this function.
So now if you want to take it a step further, on line 26, change the inside of that if statement.
What do you mean?
So what if he was to just pass item to return true?
Oh, right.
So there, now you're seeing it where we're just taking the whole concept of delegate out of it, because this is what's happening in the end.
Right.
He's just saying if, return true, passing item, but it's irrelevant because we're not doing anything with item in the return true method. All we're doing is simply just immediately returning true back.
And by the way, ignore the syntax error. That's normal because return true is not a generic method. But
yeah, but this is just to demonstrate what's really happening. It's being obfuscated in a way by using delegates and then by using the lambda, then just to simplify us having to go in there and actually write out a method. So does this make more sense?
It does. I see what you're doing. The original question he asked me is, do you know what this is going to print? And I don't see that.
Looking at the way he's got it now. So line 26, 27, 28. Now, or just look at the body of the filter list method now and think about it. What's coming in here? So may I grab the mouse for a second, Nelson?
Yeah, go ahead.
All right, thanks. So coming into here, we've got a list that's coming in.
Yeah.
So we won't worry about generics or anything else. We know that we're passing in input. So it's a very simple integer list that contains 7, 20, and 4. So you're good with that. So coming into items, we have 7, 20, and 4. So now we make a secondary list, and then we come down here, and we're going to loop through all of the items in that items list, which is 7, 20, and 4.
And for each one of those that returns true, we're going to add that item in
to this new list that's called output. So
and then we're going to return that list.
But every time we walk, so like first iteration through here, we pull the first thing out of item, stuff it into item. What is that first thing?
7.
That's right. So we got a 7. Then we come down here and we say if, And
if whatever this is happens to turn true, which we've locked to
we've
true,
locked
more
to
or
true.
less.
Very good.
There's not going to be an
Okay,
if
so
or
it's
any
true.
other situation.
So now what do we do right here?
So we're going to add that to the output.
We
so
add
we're going
what?
to add 7 in.
Excellent. And then we're not done with our for each yet. So
Right, that's going to run, and it's going to add 20, then it's going to add 4, and then when we're
Outstanding.
finished, we're going to output all of that list out.
All right, very good. Now let's come back down here. So this is where that list got outputted back to. So it's now sitting over here. And this is what I was saying earlier with now let's look at what comes next. So now we're going to walk through.
That was actually off the screen a minute ago.
Okay.
Okay, so we're outputting that entire list being 7, 20, and 4.
Okay.
For each item in the output, we're going to be spilling out whatever that item is.
Exactly.
And I've done a lot of for eaches.
But this is
so I'm cool with that.
a brand new.
Yeah. But that's a new list that we've constructed by going through our original list step by step and saying whenever this particular criteria is true, add it to the list. The only weird, I say weird in the very general sense. The weird thing here is it's not like there's ever going to be a false. We've kind of hard locked it to true.
We've hard coded that just to prove the point. And in a second, Nelson can to change the logic up here.
You could put something in that says if it's greater than 10, then add it to the list so that you'd only end up with 20 in that case.
That's the beauty about return true, taking in that item, because then we can use that item in a comparison with other stuff and determining what we want to return.
All right.
As Nelson is demonstrating there on line 37.
Next time, I'm just going to steal the mouse and scroll up and down through the entire code a few times.
Yeah, feel free to. Again, this is informal, and if you're confused, dear God, I want you to tell us.
No, and I will. It's all good.
Because if you just say thumbs up, let's go, then you're going to have somebody else out there going.
No. That's why I'm totally cool with just telling you.
But now let's work our way backwards from right here, Nelson. So he's ended up going in there and he's made this method, but now we don't want to use this method. So do you want to use the word anonymous at any point, Nelson?
The lambdas come from anonymous. I think they were called anonymous delegates.
They were.
Anonymous delegates from C# 2. So that is the correct terminology to go with it.
So it's just anonymous where we didn't go in there and hard code it out as we did line here on 35, 36, 37.
Which was kind of pointless anyway.
So if go ahead and replace this with the lambda, because I don't want to write 3 lines of code all the way up here for something that I want to express right there.
Oh, and this is awesome. So
not to mention, you may not know until you get to this point exactly what criteria you want to make the decision on anyway.
Right, and then you want to only apply that criteria here, and you don't care about reusing it or anything else. You just want it quick and simple, no 5 lines of code, thrown around your code base.
Right. You don't have to write it all out in stone way beforehand. I understand.
This is beautiful. Leaving the method above, return true, he's basically now taking that method on lines 35, 36, 37, 38, and look at that. Now look at what he's just highlighted. He just turned that into a lambda expression.
Item goes into item. It is goes into.
So yes. So goes to. So item goes to item greater than 10. Now let's look back up here at this guy. We could say the same thing. Item goes to item greater than 10, and then we're going to get a return type. And again, this is based off what's built in and being handled kind of under the hood for us with Func. Func T.
So does that sort of make sense?
It does.
We're
it does.
This function.
So now by having that there, he can now go and delete lines 35, 36, and 37. They're no longer
Honestly,
there.
the last time when my brain really hard locked, every time so far that I've really, really locked up is because I have lost track of what functionality we were supposed to be doing in the first place. The first time is because we hadn't written any. And then this time, the whole bit with writing the console was way down there, and I had actually forgotten about it.
Gotcha.
So when he said, what are we going to print, I was like, I don't even remember what we were printing in the beginning. So when we scrolled back down here and went back over this, it all started to make sense again. So yeah, next time I'm just going to steal the mouse away. And
feel free. So the bottom line before, as Nelson and I fight over the mouse, is the functionality here is simply getting stored
inside the predicate,
and then down here we make a call to it like it's just a regular method. Right. But the guts
and
of
you
that,
pass in whatever item happens to be, and
the guts of that we've defined down here in the lambda expression.
Right.
Good.
So you like it?
I do.
Zach?
I do. I'm cool with it so far.
Okay. And now remember, just like we did down here, we can define multi-line funcs. In that case, we just use curly brace syntax, just as we would with the normal method. I'm going to break this up and tab it all the way back down here. And we now have to say return.
And a terminator.
Return that, and now we can add as many lines as we want. And yeah, I don't know. Here's the cool thing I just thought of. What if we ask the user for each item that they want to add? So, write line. Or just to explain what I just did, alt inner in resharper brings up, if I undo that, brings up a little tool menu, and the one that comes up with strings that have this little curly brace syntax is surround with string.format. String.format is a function that accepts a string, and it'll replace all these little tokens in here with whatever you supply on here.
Okay.
And it's just a cleaner way to write out string manipulation, at least in my opinion. It's cleaner than just concatenating a bunch of strings.
Mm-hmm.
So we're going to say, do you want to add item? And then we're going to say response equals console.read line. If response equals yes, then return true. Otherwise, return false.
So now you're not even going to worry about math. You'll just ask the user directly.
But what are we're going to ask the user what?
You're going to ask them, you're going to show them essentially each entry in your first list and say, do you want to add this into the second list?
Okay,
yes
good.
or no?
Yep.
And based on whether they specifically type YES in all lowercase or NO, what happens if they type baseball?
It'll return false.
Okay. That's I was pretty sure about that, but I wanted to make sure.
So if I go ahead and run this, then you'll get the output that you just described. So I don't want to add the first one. I do want to add,
Gotcha.
True. So I don't want to add the first one or the second one. I do want to add the third one.
So if you really wanted to do something like this and make it worthwhile, you need to have some sort of a way to catch things like Y, because some people just respond to a computer with Y or N.
But the idea is that here we've taken what previously was a single expression,
Right.
and
You've broken it out into an entire little method body of its very own.
Right, and then this gets injected right into the system, and that's what's so cool about it.
Right.
So is there anything about delegates, lambdas, actions, or functs that you might want to go over again?
Well, let's see. A delegate is a way that you can take the functionality of a method and store it into a variable of sorts. It's a data type, more or less.
It is data.
And let's see what else we talked about.
Do you see why in C++ they have what's called function pointers? And do you see why now when somebody says
The word function pointer itself is new to me.
because we're pointing to a function,
Right. I mean, so I understand when you say it in that context. I understand exactly what
Okay,
you're talking
that's
about. Well, like when you tell me that a delegate serves as a function pointer,
It's like a function pointer.
then
to someone that's
then
coming
I'm
over
like,
from
okay,
C++.
yeah, I understand what you mean, because now I understand what delegates are and I understand their functionality,
Mhm.
so I can draw it from context.
Cool.
Which I'm sure is good enough. The lambda expression, that's actually frighteningly simple in terms of how complicated I was expecting. Especially some part of that became easier once you put it back in the context of just throwing it into curly braces and indenting it in like you would a method body, because that suddenly made the association with method bodies so much easier. As for action and func, those are two delegates.
Think of word procedure and function.
Right, and those are already those are some delegates that are already inside of C#.
And
They're in the .NET framework. Okay, and that's where my just personal verbal syntax starts to fall apart, is getting all the words right. So when
the reason I
butcher
said that just in case, Nelson, you're like, why the heck did he say procedure?
because I'm a Mel
function?
guy.
Because from the world of Mel, a procedure is just going to take in
Yeah.
your arguments, and then a function will return.
Yeah, he's just patting me on the head for being a Mel guy. That's all that is. So action is not going to take in any argument. Well, it doesn't have a return type.
There
It
you
doesn't
go.
have a return type, while func does have a return type.
And there's a bunch of them that are predefined for us.
Yeah, and I
If
mean,
you have one argument, two arguments, three arguments, etc.
I'm comfy so far.
Look at you go.
Yeah.
Well, Nelson,
Well,
was there anything else? Because I mean, was there anything else that you wanted to talk about before we get to LINQ? Or are you feeling like the next discussion would then be LINQ, and that this would bring this episode to a close?
there is one sort of thing that I really don't want to bog people down with, but it's really, really, really important to know because you will shoot yourself in the foot if you do not realize this early on. And that is the concept of hoisting. So,
Like when you
let's
pull on
say,
a rope, kind of hoisting.
yes, exactly.
Okay.
Let's say we have let's say we want this to be configurable, and we, for some stupid reason, declare this up here. So we say prompt.
Equals. Do you want to add stuff? Okay. So you could
And
just
then we're
turn
gonna-
that to prompt.
Okay. Do you notice anything kind of mind-bending about this?
Other than the string.format? No, not really.
Is that something you kind of
No. I understand that generally, but it's like we've already defined that as a string. No, only because I've followed you this far through this example. No, I'm not seeing anything particularly mind-bending, but
It should be frightening, though, that we are referencing this variable from a scope that might not even exist when this function is called. Because this function that we're defining right here can be called whenever we want.
right.
We could put it on a timer, and even after filter list returns, we could still call this function as many times as we want, and that might be long after this thing goes away.
Yeah.
So what happens is the C# compiler identifies that. It says, okay, you are using a variable that isn't directly within your own scope, so we are going to hoist this variable into this expression, to this method.
I see what you're saying. See, this is another one of those areas where, because of my background, specifically in Mel scripting, I never have to deal with that sort of thing. Once I declare a variable, it's always going to be there as a part of my script. And I don't.
And this will always be there because as long as this method body is being called on, because it has been hoisted.
Right. That's what I'm saying. In where I come from, that hoisting wouldn't necessarily be important because there wouldn't be a situation like I wouldn't have a situation where I'd have to be scared of anything I just saw. But I see what you're saying now that you put it that way.
So what if we replace this with So we imagine that 5 meg, actually what's a class? Imagine 5 meg class is a class that has 5 megabytes worth of data in it. And what we've just done is we have limited the C#'s ability to collect this memory after it's no longer being used, because it is being used. It's being used by this delegate. So as long as, or this function. So as long as this is in scope, as long as it's being used here,
Yeah.
as long as this is somewhere in memory being actively used, whatever variable you use inside of here will remain in memory, and that will include any variable that you hoist into it.
Right. That's because of the concept of hoisting.
Right.
Makes sense.
That's one thing that you will have to be very careful of.
Okay.
So,
I mean, it seems at first glance like a way that C# kind of has your back.
right. But at the same time, there might be cases where you might want to make the choice of whether or not you want to hoist this variable, or whether or not you want to turn it into something else before doing that.
So do you have a means by which you could choose not to hoist something in there?
No, if you use a variable in here that is defined up here, it will be hoisted, period. There's no choice.
Okay.
But what you can do is choose to hoist a different variable that is somehow like less, it isn't a 5 megabyte object.
Okay.
Yeah.
I get the general idea of hoisting. That last bit was a little bit vague, but only because I don't have an example, but I'm not entirely sure we really need to go into that right this second. You yourself said you didn't really want to get too bogged down with it.
No. But you just have to be aware.
Yeah.
Okay, so was there anything else you wanted to add in, Nelson?
No, I think I'm good.
Awesome. Zach, any questions? Any thoughts?
I think everything that we've got up to this point, I've got as well as I'm going to get without sitting down and trying to type through it a few times. I mean, we even
Fair
saw
enough.
between last night and tonight, while I understood the concepts of everything we've been talking about, I was still very rusty in performing it because of that critical thing. Like, okay, we got done with last night, and that pretty much wrapped up our day. And then I came back in, and I've been doing my 3D busting all day, and I haven't taken the time to go back over that video and try coding that. If that proves nothing to anybody watching this video, it shows that just watching the video will often not get you very far.
You've got to get in there and work
just,
with it.
Yeah, make up some fun code. You know, even if it does technically nothing important, but just take this stuff and try to put it to good use.
So if Nelson's going to ask you to type some stuff tomorrow, you're going to...
Yeah, as long as I can, I'll ask you if I can get some time to type some stuff on the front end so that I'll be prepared.
Just
but
as soon as you clock out. No,
yeah, exactly. Yeah, you're not doing it on my clock, buddy.
Yeah, no, of course. All right, well, that's excellent. Nelson, as always, you did an outstanding job. Zach, thank you for all the questions tossing out and staying honest when something seemed confusing or
Thank you.
weren't sure. And that will wrap up this episode of Nelson's Corner. Thanks a lot, everyone.